Decoder is a combinational circuit that converts binary information from n input lines to maximum of 2 raised to n unique output lines. Generally, a decoder is also called as an n to m line decoder. A decoder is used to convert binary form to any other desired form. This decoder can be used to convert binary number to octal number, octal to hexadecimal, and various other forms of numbers. So let's study the decoders, how they can be processed, and what are the applications for which decoders are used. Now the decoders again are of two types: active high decoders and active low decoders. This 3 to 8 line decoder, this is the example or the logical diagram for 3 to 8 line decoders. So before going through the logical diagram, let's have a rough block diagram of 3 to 8 line decoder. Okay, so let's start with the 2 to 4 line decoder. As we have said, a decoder is a circuit which has two inputs, let's say A and B, and 4 outputs. As we have studied, if n number of inputs, n is the number of inputs, then the output will be 2 raised to n. Here n is 2. N is 2 in this case, therefore output is equal to 2 raised to 2, which is 4. Okay. It has one select line, also called as enable. This is a block diagram for active high decoder. Similarly, for 3 to 8 line decoders, we can have a block diagram as this is the block diagram for 3 to 8 line, where there are 3 inputs. Okay, the nomenclature is like 2 cross 4, 2:4. That is 2 input, 4 outputs. Similarly, this is called as 3 cross 8 decoder, that is 3 input, and we have output will be 2 raised to 3, which gives 8, that is 0, 1, 2, 3, and so on till 8. So total number will be 8. So let's study how the decoder works. So before going through 3:8 decoder, let's study a simple form of decoder, which is 2:4 decoder. Okay, 2:4 decoder will have 2 cross 4 decoder, which is active high. Okay, active high decoder. Let's say 2 cross 4 means there will be 2 inputs, A, B, 0, 0, 0, 1, 1, 0, 1, 1. So the circuit diagram for 2 cross 4 decoder will be as follows: A, B, that is 2 inputs, 2 cross 4, 2 raised to 2 outputs, that is 4 outputs. This will be, let's say, Y0, Y1, Y2, Y3. Okay, and it has one enable line for active high. Okay, if it's active low, we'll discuss the active low also. Let's say for active high, the outputs are as follows: Y0, Y1, Y2, Y3. Since this is 0, the output will show Y0, that is Y0 is selected as high. Now this 1 is written for Y0 because it is an active high. The rest will show 0, 0, 0. Now the value of this is 1, so Y1 will be high, rest all will be 0. Similarly, 1, 0, it gives 2, that is Y2 will be high, rest all will be 0. And 3, A and B, it gives 3, so Y3 will be high, rest all will be 0. This is for active high input. Your active high input has 1 for the selected. Similarly, for active low block diagram will be for 2:4, two inputs. Now the active low decoder is represented as a bubble. This bubble denotes active. This is the enable pin. Rest all remains the same. A, B, Y0, Y1, Y2 and Y3. There is Y0, Y1, Y2, Y3. So let's see the working of active low decoder. YAB 0001. Okay, for active low A B 0001 1011. So puts are Y0, Y1, Y2, Y3. Active low decoder outputs. Okay, since active low decoder are always represented by 0. That is, in this case, AB00, that is pin Y0 is selected. Okay, so we write 0 for the selected pin in case of active low decoder. Okay, 0. Rest all are selected as 1. Similarly, here 1 is selected, so Y1 will be having 0, rest all 1. Now here 2, therefore Y2 is selected, rest all are 1. And the last case is Y3, therefore Y3 will have 0, rest all 1. So the block diagram or the logic diagram for 2S21 decoder, the logic diagram for 2S21 decoder for active high can be drawn as: this is enable, this is first output A, this is first input A, second input B. The other will be having one inverter or NOT gate. Similarly, B will be having one inverter or NOT gate. And the output Y0 will be as seen from the active high decoder A, B 00011011. The outputs Y0, Y1, Y2, Y3. Y0 selected, rest all 0, Y1 selected, rest all 0, Y2 selected, rest all 0 for active high. Similarly, Y3 selected, rest all 0. This is the truth table for the active high decoders. The equation for Y0 can be written as Y0 will be, since A0, B0, A bar, B bar. Now, Y1 can be written as A bar B. Okay, Y1 is A bar B. Y2 will be A B bar. Y2 will be A B bar. Okay, this Y2, and this Y3 will be A1 B1. So Y3 will be A B. So we can draw the circuit diagram using gates for 2S24 decoder as Y0 is A bar B bar. So one will be A bar, one inverter gives A, the other B, and since active high, the enable pin will always be connected. This is Y0. Similarly, let's check out for Y2. Y2 will be A and B bar, and the third pin will be the enable pin, as the decoder will work only when the enable pin is high. Similarly, we can draw for Y3 and Y4. So this is the logic diagram for 2x4 decoder. Now let's study the 3x8 decoder. The same can be seen In this circuit diagram, the 3 cross 8 decoder, 0 0 0 1 2 3, okay, 4 5 6 7. Let's see this. Since 0, therefore D0 selected, 1, therefore D1 selected, 2, therefore here D2 selected, rest all 0, 3, this is 3, therefore D3 selected, rest all 0, 4, the binary equivalent is 4, the binary equivalent is 4, therefore D4 selected, this is 5, therefore D5 selected, 6, therefore D6 selected, this is 7, therefore D7 selected, and so on. So as we can see from the equation for D0 is having X bar, Y bar, Z bar. Why Y bar, Z bar? It's because X is 0, Y is 0, Z is 0. Since 3 inputs, therefore the D0 will have multiplication of X bar, Y bar, Z bar. That is, we can check out from this. X bar, that is X0 bar, Y bar is represented as X1, Y is represented as X1, so Y X1 bar. Similarly, Z bar, that is X2 bar. Similarly, let's check for X, Y, Z, which is having 1, 1, 1. So D7 is selected. Therefore, D7 will be X0, which is X, X1, which is Y, X2, which is Z. Hence, 3s to 8 light decoder can have 2 raised to n number of outputs, where n is the number of select lines. Similarly, let's check the application, how a decoder can be used, or what all circuits can we execute using decoders. The first application, or the most simplest application we can say, is decoder can be used to create a half adder. Let's check out how the decoder can be used to construct a half adder. Design half adder using decoder. Now we will use 2s to 4 decoder. Okay. So before designing the half adder, we'll just write some basic equations of half adder. Half adder consists of sum, which is having equation as A XOR B, and the other output will be carry, which will have equation as AB. Therefore, the half adder should be such that 2 inputs, 4 outputs, 1 enable line. So the half adder should be such that it should have the equation as A XOR B, or A bar B plus AB bar. Okay, so we can write for this A bar is 0, B is 1, and for this we can write as A is 1, B bar is 0. That is, if we write the decimal equivalent for this will be 1 and this will be 2. So the outputs here, inputs are AB, the outputs will be Y0, Y1, Y2, Y3. Okay, we can check out that here for this equation A bar B plus AB bar, this is 1, that is Y1 will be selected. Now the second output is A, which is 1, B bar, which is 0, that is 2, therefore Y2 will be selected. Now since there is a plus, we will have an OR gate. This is sum. Now the carry is AB, that is A will be 1, B will be 1, which gives 3, therefore Y3 will be selected, which will have a carry. Hence a 2x4 decoder has been used to utilize as a half adder. Similarly, a multiple output system can be designed by single encoder as it has multiple outputs. As we have seen from the block diagrams, decoders and encoders are 2 raised to n outputs, and where n is the number of inputs. So that is the reason we can have a multiple output systems can be designed by single encoder. Now, similarly, let's study half adder using active low decoder. It was active high decoder. Now let's study the half adder by active low decoder. Okay, so let's draw the basic block diagram for half adder for active low decoder. Active low decoder, this is two input A, B, this will be Y0, Y1, Y2, Y2. Okay, the sum will be A XOR B, A bar B plus AB bar. Okay, that is the sum will be Y1 plus Y2. To use this equation using half adder by active low, let's use by Boolean expression. Y bar is equal to Y1 plus Y2 to the whole bar. Again we do bar, that is the equation remains the same. So after simplifying this, we get it as Y1 bar into Y2 bar the whole bar. Okay, so active low decoder can be implemented for half adder by using NAND gate. So this is the equation for sum, and similarly this is the equation for carry. So half adder using active low decoder is implemented using NAND gate, and half adder using active high decoder is implemented using OR gate.